Thank you for click on this video. I Sajal Sasmal welcome you to complete lecture series of solar photovoltaics. Please click on description for playlist of complete solar cell tutorial. Let's start. Diffusion. When light is incident on a solar cell, carriers get generated at that surface, but not in the bulk of the solar cell. This creates a carrier concentration gradient within the semiconductor. When a carrier concentration gradient exists in the semiconductor, through random motion, carriers will have a net movement from areas of high carrier concentration to areas of low concentration in the process of diffusion. With time, these carriers will diffuse throughout the cell until the concentration is uniform. The constant random motion of carriers can lead to a net movement of carriers if one particular region has a higher concentration of carriers than another region, a concentration gradient between the high carrier concentration region and the low carrier concentration region. The net movement of carriers is therefore from areas of high concentration to low. If we let random movement do its thing, over time, the carriers will become evenly spread across the space through random motion alone. Diffusion is the random scattering of carriers to produce a uniform distribution. One major effect of diffusion is that, with time, it evens out the carrier concentrations in a device, such as those induced by generation and recombination, without an external force being applied to the device. This is shown in the animation below, in which one region of the device has a high concentration of electrons and the other has a high concentration of holes. Due purely to the random movement of carriers, the two concentrations will become uniform throughout the material, over time. The holes blue and the electrons red move from areas of high concentration to low concentration within a semiconductor towards an even distribution. The holes colored blue have a lower diffusivity than the electrons colored red, and so take longer to fill the full space. Diffusion equation derivation. It is known from the molecular physics that the flux of diffusing particles is proportional to the concentration gradient. Spreading of a pulse of electrons by diffusion. Arbitrary part of n x is divided into the segments of length equal to a mean free path for the electrons. Concentration is supposed to be constant for every segment. Rate of diffusion for electrons in semiconductors equals electron flux density equals number of electrons passing x0 per unit time per unit area. Consider small segments of width L to the left and right of x0 and approximate the electron concentrations N1 and N2 in these segments as uniform. The difference in electron concentration between the 2 points N1 and N2 needs to be written in terms that we understand. We can define both N1 and N2 using an excerpt of the above graph. We assume L is very small, and therefore can use the slope at XO in order to determine the electron concentration N at XO plus or minus 0.5. dN is the electron diffusion coefficient with units square centimeter per second. The minus sign arises from the fact that the vector of the concentration gradient is directed toward the increase of the concentration, while the particles diffuse to the area with lower concentration. Direction of the concentration gradient is opposite to the direction of the carrier motion, with the result that the formula for the carrier flux density should have a minus sign. Consider the length dx of semiconductor and movement of holes through it. The net increase in hole concentration per unit time is the difference between the flux of holes entering and leaving the volume A delta x plus generation rate and minus recombination rate. Thank you for watching the video. Please like and share this video. I will be so happy if you subscribe my YouTube channel. Click on description for playlist of complete solar cell tutorial.